Now let us cover section 8.2, which is the Pythagorean Theorem and its converse. The Pythagorean Theorem relates the length of the hypotenuse and legs of a right triangle. So let us say we have a right triangle. This is the hypotenuse. And the hypotenuse is the side opposite the right angle, and it's always the longest side. And then we have our legs. And the legs are the side adjacent to the right angle. The Pythagorean theorem states that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. The equation for this theorem is c squared equals a squared plus b squared. C represents the hypotenuse, and A and B are the legs. A set of non-zero numbers A, B, and C that satisfy the equation c squared equals a squared plus b squared is known as the Pythagorean triple. Let us apply what we just learned by trying a couple of examples. So in this problem right here, this would be the hypotenuse, and these are the legs. Now we will just use the equation. So we get x squared equals 14 squared plus 8 squared. And it does not matter which leg you plug in first. So we get x squared equals 196 plus 64. We get x squared equals 260. We'll take the square root of both sides, and we end up with x. And we could split this into factors that have a perfect square. So we'll split it into radical 4 times radical 65. And the square root of 4 is 2, so we end up with x equals 2 radical 65. And this is not a Pythagorean triple, because all the sides are not whole numbers. So, not a Pythagorean triple. Now let us try another example. So this would be the hypotenuse, and these are the legs. Now this example is different because the value of the hypotenuse is given to us. But we use the same equation. So we get 25 squared equals y squared plus 7 squared. We get 625 equals y squared plus 49. Now we have to subtract 49 from both sides of the equation. And this will isolate the y term. So we end up with 576 equals y squared. Take the square root of both sides, and we end up with 24 equals y. This example is a Pythagorean triple because all of the sides are whole numbers, and it satisfies the equation c squared equals a squared plus b squared. Now let us talk about the converse of the Pythagorean theorem. This states if the square of the length of one side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if c squared equals a squared plus b squared, then the triangle is a right triangle. We can also classify the triangle as obtuse or acute using the Pythagorean theorem. So the theorems are: if c squared is smaller than a squared plus b squared, the triangle is acute. If c squared is greater than a squared plus b squared, the triangle is obtuse. Let us try this with the numbers 4, 6, and 15. All we have to do is plug it into the Pythagorean theorem equation. So we get 15 squared equals 4 squared plus 6 squared. And remember, c is the hypotenuse, so it's always going to be the longest length or the bigger number. So we get 225 equals 16 plus 36. We end up with 225 equals 52. And 225 is bigger than 52, so this is an obtuse triangle. Let us do another problem with radical 5, radical 7, and 3. So we get 3 squared equals radical 5 squared plus radical 7 squared. By squaring the radicals, they eliminate. So we end up with 9 equals 5 plus 7. And then we get 9 equals 12. 9 is smaller than 12. So this is an acute triangle. And if you get both sides of the equal sign to equal the same number, then it is a right triangle. That is all for section 8.2, using the Pythagorean theorem and its converse. Any questions, feel free to ask. Have a nice day.